Okay, hello, welcome back to another video log recording session where I talk about genetic algorithms and some other stuff, rant about other stuff, etc. The notebook is titled Genetic Algorithms, Grid Search 340 Items, allfx, as in all procreate functions. This notebook was created to assess the impact that the length of genome has on the evolution and the effectiveness of entity generation with a population of null entities that contain nothing to begin with, or what I call void genes. But try that with try that with every parent selection scheme. This notebook deals with 40 items, and usually the peak is at around 1000, and the population was set to 500 entities. Was it 500? I don't think it's 500. I think it's it's 1000, but 500 is for the generation for the generation. So population is 1000 and generations is 500. So that's obviously that's something wrong. In this session, I ran the entire notebook because I wanted to show the plots and explore, and also record that on video. So yeah, so all things are the same, except that, like I said, except the population size and the number for the total generations. So max constraint is set to 6500 when the total sum of all physical weights or constraints is 8420, and the sum of all utility values is 1180 when you add up all the 40 items. So that we do the same, but for each one of the procreate functions that I have previously introduced. Yeah, and the entire process for 500 generations each, and 5 times per procreate function. So that's 5 times 10 procreate functions times 500 generations times 1000 entities. And it took about 2000 seconds. And here is an empty plot. Before I show any plots, the red dotted line is for the top value, the highest that the average of top 30 entities have shown or have been, or rather was the highest it ever was. And the blue line is just 1000. So I put the line at 1000, blue line at 1000, because that usually is where the peak forms, slightly above or slightly below, but most of the times above. So, and this time I fixed the x-axis and the y-axis so that the plot stays the same in terms of scale. So these two that I'm going to uncomment are for the are the results of the first two runs when I used the Lonely Island, the self-replicate procreate function. And when I run that, I see that there are no dips here. However, it doesn't peak either. It doesn't go well. If these were the only things that I am seeing right now, I could say that, oh, this is good. But you know, this is somewhat satisfactory. There are no dips for the self-replication. So I'm just going to leave one. And for the next function is for the monopoly elitist. Remember, the top entity gets to procreate with the other top entities, top 10% of the entities, but parent 1 is always fixed to be the top entity. Rather the other way around, the top entity is always fixed to be parent 1. And this is what happens. See, for the monopoly elitist procreate function, it does peak, and then it falls down and plateaus outwards, so there is a dip. Same for the second run, and probably for the third run as well, fourth run, fifth run. Yeah, it's all the same. So I'm just going to leave that. Two graphs there. The third one is the monopoly winner takes all. This is where the top entity is always fixed, and that as parent 1, and parent 1 gets to choose whichever entity it is in the entire population, regardless of their summed utility value. So here we go. That's hard to see, so let's put that. This orange line is that, the second one. So it's about the same. It peaks and then it plateaus outwards to the right. However, if we compare that to the monopoly elitist, it doesn't. The peak isn't as high, and the plateau level is slightly lower. So that's that. Let's leave these. Yeah, and the next one is oligopoly. The top few take all, as in only the top few, top 10%, for example, in this case, I think, get to procreate among themselves. So we put that, and I uncomment this and I show the graph, and this is what I get. And that's rather hard to see. See, it peaks and then it dips, and it still doesn't reach the red line. Spoiler, that was for the fourth run of this procreate scheme. It meets the red line and then it dips. There is a dip, and it plateaus outwards. Yeah. So so far, the oligopoly procreate function seem to have the highest peak. Again, this is the self-replicate. Let's go try favoring highs. Not as high. Kind of high. What if we were to do it for the third one? Kind of high, but it's still declines. there's still a decline, and then it plateaus outwards. And then for the fifth one, or rather the sixth one, is the proportional procreate scheme, procreate function, and we see that there is no dip, but it's the summed utility value, the average of the summed utility values for the top 30 entities doesn't go as high, so that's a shame. Same for the second one. And less favoring highs, we can try that. We do see a peak, but we see a dip too. For the eighth one is the opposites attract, no dip but not as high. Same for the second run of the function. The ninth one is a bird of feather, where similar entities get to procreate. This one's not performing. There's no peak, there's no dip. If there's no peak, there's no dip either. Kind of. Same there. And the 10th one is pure chance. About the same. About the same too. So right now the ones that show the ones that reach or go above 900 ever is kind of the self-replicate procreate function, and let's just put another 900 there. 900, so self-replicate, and the elitist 2, and that one being monopoly, winner takes all, and this one the oligopoly, top few take all, or rather only the top few get to procreate. So, but my main concern has not been dealt with, that being that I don't want the dip to be this big. I'm just going to plot all the 5 runs for oligopoly, and this is what I got. So the dip is, or rather the peak is at 1031.3333. That's the red dotted line. And then the peak, the plateau level is slightly below 900. So if we do the math, should I do the math? I don't know. So 1031.33 divided by let's just say 890. So there's about a 14% loss of information. So 14%. Yeah. So my next notebook is going to be about how I can actually combine the usage of these procreate functions, not rewrite the functions, but use the functions either alternatively, like in an alternating manner, or switch from one to the other only once or twice, or just pick a random function from the 10 functions to procreate for that generation. Of course, I can in the future write more procreate functions that that do a mixture of 2 or 3 of these functions, but I think I think I should do that later. Once after I've done using these functions, you know, together as a combination. Not as in but still keep it to one procreate function per generation. But and after that, I can try doing 2 or more procreate functions per generation, so that I can minimize the dip or control the dip. So that's about it. It is weird because sometimes it showed that like in the original file, I'll also show the original file that I haven't changed, that I haven't altered. That red dotted line was probably for favoring highs, but this time it just turned out, and the one before this, it turned out that oligopoly also performed quite well, or better, showed higher peaks than favoring highs. I don't know why that is. I'll also have to look into that too. Nope. So this is what it looks like. So no dip, and higher plateau is the self-replicate, and other than that, if there were no dips, the plateau level was at a very, no, I don't want to say that, it was at a relatively lower level, around slightly above 800. So my goal would be to rather bring this red line all the way up to here so that there's no dip, or rather the other way around, bring this blue line all the way up to here. But maybe that's a good thing or a bad thing, we'll never know. I mean, I don't know for now. I'll probably never know, or I might know, but yeah, you get the point. So that's it. Thank you for watching. Bye. See you soon.